going to teach you how to convert from radians to degrees. To start off, we always need to know that pi radians equals 180 degrees. So here we have 3 pi over 2 radians. First you would substitute 180 for pi, and then you would multiply 3 times 180 to get 540. Then you would divide that by 2 to get 270 degrees. Over here we have negative 7 pi over 6. First, you would substitute 180 for pi. Then you would take 7 times 180 to get 1260, and then you would divide that by 6 to get negative 210 degrees. I'm going to teach you how to convert from degrees to radians. Here we have 30 degrees. First, you will multiply that by pi over 180 to get 30 pi over 180, and then you will simplify that to get pi over 6. Then we have 150 degrees. You'll take that times pi over 180, and you'll simplify to get 5 pi over 6. Today I'm going to be showing you how to graph trig functions using transformations. Right here is the general equation for all trig functions. A is the amplitude, which is a vertical stretch, or the distance away from the median. When A is negated, the whole graph is flipped over the x-axis. B stretches and compresses the graph horizontally, which determines the period of the graph. C determines a shift left or right, and D shifts the graphs up or down. And D is also the median of the graph. The graphs behind me are both the sine graph and the cosine graph. The sine graph being in blue and the cosine graph being in green. You'll notice that they have a very similar shape. This is because they are cofunctions. However, the sine graph begins at a median, while the cosine graph starts at a peak, or the height of the graph. They both have the same period, which means it's the same amount of time for the graph's pattern to repeat, which is 2 pi. You'll notice that the height of the graph only goes one unit in the positive direction and 1 unit in the negative direction, because A, the value of A of these two graphs, is only 1. You'll also notice that the graph is neither shifted vertically or horizontally because C and D are both 0. Let's graph y equals negative 2 cosine of 2x. Okay, first let's identify all of the parts that we need. The period is always determined using 2 pi over b. So b is 2, so that will give us 2 pi over 2, which is just pi. So the period of this particular function is pi. The time it takes for one cycle to be completed is only pi, instead of 2 pi, which is the normal period for a cosine graph. The amplitude determined by A is 2, which means the graph will be 2 units away from the median in both the positive and negative directions. Okay, the graph is not going to stretch vertically or horizontally because C and D are both 0. But if there was a plus, let's say 2 for instance, on the end of this, then that would cause the graph to shift up 2 units, and the median would no longer be 0, it would become 2. Now we have all the information we need to graph the trig function. Usually, the cosine graph starts at the peak, but because it's negated, we're going to start at the very bottom and work our way up from there. Okay, you'll notice the graph starts at a low, goes to the median, to the height, back to the median, and down again. This will repeat infinite number of times.
Alright. start out with sine of 105 degrees, and the best way to start is by breaking it down into two more common angles. Once you're there, you can use the sum and difference formulas. Like, it would break down into sine of u times cosine of v plus cosine of u times sine of v. And then with your 30, 60, 90 triangles, the sine of 60 is square root of 3 over 2. The cosine of 45 is square root of 2 over 2. Plus cosine of 60 is 1/2. And the sine of 45 is square root of 2 over 2. And then you can multiply straight across, so you get square root of 6 over 4 plus square root of 2 over 4. And then that can be condensed to square root of 6 plus square root of 2 over 4.
Trig identities. So when working with trig identities, you can only work with one side of the equal sign, and today for this particular problem, we're gonna simplify the left side to make it look exactly like the right. So cosecant squared x is equivalent to 1 over sine squared x, which is all over cotangent of x. And cotangent of x equals cosine of x over sine of x, but it's being divided, so we take the reciprocal of that and multiply it to the numerator. So our new expression becomes 1 over sine squared x times sine x over cosine x, which is the reciprocal of cotangent of x. And here the sine x cancels, and that leaves us with sine x in the denominator. So this is 1 over sine x cosine x. And you can split the fraction into 1 over sine x times 1 over cosine x. 1 over sine x is the same as cosecant x. And 1 over cosine x is the same as secant x. And that is exactly what we have over here. So cosecant x times secant x equals cosecant x times secant x. And that is how we verified this particular trig identity. Particular trig identity, we have to simplify the left side to make it equal secant of x. So since the numerator says tan x times cotangent of x, you can rewrite that as tan x times 1 over tan x, and all of that is over cosine x. Tan x times 1 over tan x is just 1, so the new simplified expression is 1 over cosine x. And 1 over cosine x is the same as secant x, which is exactly the same on the right side. You verified this trig identity.